All right. Now we have to take on a certain subtle, difficult matter. I don't mean to deter you, but I want to be honest with you. This is a part of Python, what I'm about to discuss, that has caused me difficulty in the past, and I do believe I'm clear about it now. But we do have to pause and talk about it. All right, so just a little bit of basic review. You know what a function is, right? A function takes certain values that we call their arguments, and then it does some kind of computation, manipulation, and at the end returns some value. That's what functions do, right? They take arguments, they do a computation, they return a value, and that for us up until this point, that's been it, right? That's all that can happen inside of a function. However, that's not the end of the story about what can happen inside of a function with Python. And this is linked to something that I brought up in a previous lesson about lists. That is that lists are mutable. Okay, there are certain functions that act on a list that actually mutate that list. Now, what's the connection here? Well, I have to introduce some new language for you. Um, I have to talk about functions that are fruitful, F-R-U-I-T-F-U-L, that is, that have fruit, functions that are fruitless, and also functions that are mutators and functions that are non-mutators. Okay, so we'll need examples of this to make all of this clear. Okay, so let me create a list, and I'll make it just really simple. I'll just put the integers 1 and 2 and 3 in this list. Now let's consider an example of a function that is a fruitful non-mutator. I'll tell you what, I'll actually type this in to the code editor just so you can make sure that you understand what it is that I've said. Okay, so let us consider a function that is a fruitful non-mutator. So let's see that initially. I'll just use the length function. We saw this function last time. It returns the number of elements in a list, so of course that should be 3 in this case. So there we go. Okay, so what does it mean to say that this function is fruitful? It means that it returns a value. A fruitful function returns a value. So the call to length in this case, with L that contains 1 and 2 and 3, the return value is 3. So there it is, it's fruitful, okay? But also this function is a non-mutator, okay? That is, it does not change the argument that was sent to the function, and that argument was the list L that contains 1 and 2 and 3. So if now, after the call to the links function, we examine the contents of L, we see that they are the same as what they were before. So the length function, the len function, is a fruitful non-mutator. But there is another kind of function in Python, and that kind of function is called, there'll actually be 3 kinds that we have to consider, a fruitless mutator, okay? Now, what does it mean to say that it's fruitless? That means to say that it doesn't have a return value. That's not exactly right, and we'll have to come and talk about that later on, but I'll let that stand for now. It's a function that doesn't have a return value. It's very strange to think about it, given all that we've said about functions before, but this is one of the possibilities in Python, to have a function that doesn't return a value at all. But that doesn't mean it doesn't do anything, because, what's the point if it doesn't do anything at all? It does do something, and what it does is it mutates an object, okay? And an example of that is the function that we saw last time, which is the append function. Okay, so there it is, l.append 4. We know the function name is append. We know that the primary argument is L. We know that the secondary argument is 4, and we know what this does. It adds 4 onto the list L, so it'll be 1, 2, 3, 4. So let me hit return, and then we should stop, okay? Compare this to the previous line in the console where we found, where we had length L, len L. When I typed len L, something was returned to me, and then that was printed into the console. That is the 3. But when I typed in l.append 4, nothing appeared in the console, okay? Something happened, but no value was returned, and that's why nothing was printed in the console. So a call to append doesn't return a value. What did append do? Instead, it mutated L. So if we now look at the value of L in the console, we see what it is. It is 1, 2, 3, 4. Okay, so append does something. It doesn't return a value. That's not the way that it does something. Instead, the way that it does something is it mutates the list that was sent to append as the argument. Okay, and finally, we have another possibility here. Again, I'll put this into the code editor. We have fruitful mutators. Not sure why I put commas in there, but there it is. We have fruitful mutators. Now, what would that have to be? Well, fruitful means that it returns a value. Okay, so if I call a fruitful mutator in the console, after I hit return, something will be printed in the console. That is the return value. But we actually mutate as well. Okay, here's an example of such a function as that, the so-called pop function, which you will no doubt use. Pop. And this is a function call, so we need parentheses, but initially we won't put anything inside of those parentheses. We'll consider what we could put in them later. But what we have right here, just l.pop with no argument, um, is this. It first of all removes the final element of the list. That is, it mutates it, sort of the opposite of append, as it were. And then it returns that value that was popped off the end of the list. Okay, so when I hit return, I should see a 4, and I do. That's the return value of the function. But notice that when I consider the value of L now, it no longer has the 4 at the end, so L was mutated. So we did both. We mutated the list, and we actually returned a value as well. And if I wanted to, I could pop it another time. So there it is, the final element of the list is 3, and if I were to look at L again, yeah, there's nothing at all. So again, it's fruitful because it returns a value, the final element of the list, and it also mutates the list that was sent. Okay, now, in the next lesson, we're going to have to come and talk about certain kinds of dangers that are involved in list mutation. But for right now, let's just simply look at examples of list mutators. You will find these extremely convenient. You will find these extremely convenient. You'll use them all throughout the functions that I want you to write for the chapter. And these are, of course, detailed in the chapter. You will find the syntax there together with examples. But let's look at some examples of this. First of all, just review the append function. So at this moment in time, L is the list that contains the elements 1 and 2. So I can append 3. And then if I look at L, it's 1, 2, 3. And let me do something else to make sure that you're clear about a point that I made earlier. L.append 4. Notice that nothing was printed in the console. That's because it's fruitless. There's no return value, but it was a mutator. It did actually change the list. So the list L now contains the elements 1 and 2 and 3 and 4. Okay, so that's the first of our mutator functions for lists, the append function. There's another that's called insert. So L.insert. Now, how does insert work? Again, you can consult my website for the syntax on this. But what insert does is it puts an object at a certain index. Okay, so how about a string? And let's put that at index 1. Okay, now what will happen in this case? Well, once I hit return, I will mutate L. And then after mutation, spam will be the element in index 1, and everything after that will be shifted over. So I don't overwrite an element. Instead, I insert an element, and then everything after gets shifted over to the right. So, and oops, I got this backwards. The order of the arguments is not object to insert and then index. It's the other way around. So the index comes first, and then the object that you wish to insert comes second. I should be more careful, but that's the way this works. So yeah, let's now look at L, and what happened is exactly what I said would happen. Notice that the object spam was inserted into my list. It was inserted at index 1, and everything after was simply shifted over. Okay, so there's the insert function. There's also a remove function. What the remove function does is it removes an element of the list. So let's try to remove the 1. Ooh, apparently that was successful. There was no return value. That's fruitless, but it was a mutator, so the 1 is now gone. And we could also, if we wanted to, remove 4. If we were to look at L, the 4 is gone. Now here's a good question. Let's say that the list contains more than one instance of that particular element. What happens? Well, let's change L just a little bit. So let us perhaps append spam at the end. So there's L now, spam 2, 3, and then spam again. And then let's do L.remove spam. Ooh, apparently that worked. Let's see what it is. Oh, it removes the first instance. So that's just how remove works. If there are multiple elements, multiple instances of that particular item that you wish to remove, it always removes the first. Here is another function. It's the del function. The syntax here is different. It doesn't use the dot notation. Sorry, Python allows many ways for function calls. This is simply how del works. So it's del in the name of list. and then we provide an index. Okay, so let us remove the item at index 0. Okay, notice that that was fruitless. Nothing was printed in the console, but I did mutate L. And sure enough, the item that was index 0 is now gone. And that was, of course, the 2. We saw a pop just a moment ago. Um, we can pop an element. And notice that something was printed out in the console. That is the final element. That's the element that was returned. Pop is fruitful, but it's also a mutator. That element is now gone. And if I were to pop one more time, probably guess what will happen. It removes the final element, which is the only element, and that is the 3. And at this point in time, L is now empty. Okay, so let's put some objects back in L. How about just 2, 3? So we can see L, it's back to 1, 2, 3. Um, we can also pop from a particular index. So we can go L dot pop about 1. Okay, so that 1 that comes after the pop, that represents an index. So what it'll do is it will remove the element at index 1 and return that element. That's, of course, a 2. So there's the 2. And if we were to look back at L, that should contain the 1 and the 3, and it exactly does. Okay. And then there's a final way that we can mutate a list. It's very much like that index operator that we talked about before that returns an element from a list, but now we can use it to overwrite. Okay, so L is now the list that contains 1 and 3, but what if we wish to say that the element at index 0 should be a 2 instead? Okay, well, we're about to overwrite. So this says, make the element at index 0 a 2. Notice that that was fruitless, nothing appeared in the console, but it was a mutator. We did change the list, and sure enough, the element at index 0 is now a 2. So there's the story for today. It's a bit shorter. We had to make this distinction between fruitful and fruitless functions, and we had to make a distinction between mutators and non-mutators. And what we'll have to talk about next time is a certain sort of danger that arises when you write a function that is a mutator type function. You can get yourself into a world of hurt, and I will show you exactly how this can happen. See you next time.